secureblue is a security-focused desktop and server Linux operating system. This is basically a Linux distro that tries to be more secure than the typical Linux OS. I learned about secureblue recently after I read some articles about all the different ways in which Linux is a security nightmare. If that doesn't sound quite right to you, I thought the same thing. Linux is the OS that powers the web. Surely it must be secure. Nope. Turns out that for desktop usage especially, it really isn't. I'll leave links to those articles in the description, but in this video I'm going to talk a bit about secureblue and then go over my experiences with installing and using it. So the best place to start is on the secureblue website. We can see that the authors are really honest and direct about what they're trying to do here. Quote, "The security architecture of desktop Linux is broadly and significantly lacking. Secureblue is for those whose first priority is using Linux, and second priority is security. Secureblue does not claim to be the most secure option available on the desktop. We are limited in that regard by the current state of desktop Linux standardization, tooling, and upstream security development. What we aim for instead is to be the most secure option for those who already intend to use Linux. As such, if security is your first priority, secureblue may not be the best option for you." So if you're still watching this video, you're probably one of the people that the authors are talking about here, like me. I'm stuck with Linux because I'm never going to use Windows in my life unless I'm being paid for it, and the same goes for macOS, but I do want security insofar as I can get it. Another thing you'll learn on the homepage is that secureblue is based on Fedora, specifically Fedora Atomic. Now, Fedora Atomic is a whole topic in and of itself, so if you've never heard about it before, you should pause the video now and look into it. But the basic summary is that in an Atomic OS, all your packages and core OS files are read-only. They cannot be modified during normal operation. On top of that, any changes that you make to the OS are made in a so-called atomic manner, which means that if you accidentally break something or if something goes wrong during an update, it's very easy to roll back those changes. Also, on an Atomic OS, you're expected to install all of your apps and packages through some containerized or isolated format wherever possible, usually Flatpak, instead of as traditional OS packages. This is not a video about Flatpaks or container software, so you should already know a bit about those, or else some of this video might not make sense to you. Now, this is a really good website. They have a very informative features page listing everything that secureblue does to make Fedora more secure, along with a very long and detailed FAQ page, which is pretty reminiscent of the Graphene OS FAQ page if you've seen that. But instead of going over all of this with you, I'm just going to dive into my experience and I will refer back to these pages throughout the video. I've been using secureblue for a few weeks now, at first on a small home server that's specifically used for testing, and then more recently on my main laptop as well. I've done all sorts of things on it, from gaming to software development to self-hosting various cloud services. I'm going to start by approaching this from the perspective of a novice Linux user, somebody who is familiar with Linux distros and knows how to install them, but who is not a developer or a power user and is not very comfortable in the command line. And then as we go along, the issues and use cases will get more and more advanced and niche and focused on power users. One thing I want to say here is that the focus of this video will mainly be the problems and challenges that I faced while using this OS. Now, that's not because secureblue is just nothing but trouble with no positives. It's just that the issues I faced were the only interesting part of the experience on a practical level. Secureblue does have a ton of improvements, but most of those are under the hood. They don't really show up in the day-to-day experience, except when things go wrong and don't work as expected. Outside of those security improvements, secureblue really just feels like regular normal Fedora. So that's why the only interesting parts of my experience were the challenges. So if this video feels like it has a negative vibe, then that's probably why. I do recommend you read their website where they explain all of their security improvements much better than I could anyways. So the first thing you need to do is obviously install secureblue, and the process should be very familiar. They have a few different variants, so you can pick between 3 different desktop environments and you can choose to include NVIDIA drivers if you need them. There are also instructions to verify the ISO, but from there we can skip the rest of the installation process because it's identical to that of any other distro. As soon as I got the thing booted up, I had to change the wallpaper because for some reason it had this weird thin border that made it look just wrong. After that was done, I decided to see if there were any OS updates available. The App Store told me that there were none, but there was a firmware update for my CPU. So I installed the firmware update through the graphical app store, like a normal user would, and then I rebooted. After the reboot, I came back to the store only to see that the update was still there. So this was not a good first impression. So then I tried using the command line to do it. secureblue comes with a special command called ujust that lets you do a bunch of different things in the OS. In this case, I just needed to run ujust update firmware. It seemed to work, and it asked me to reboot, but I declined, because now I was suspicious of this graphical app store. It has this happy sunshine graphic telling me that there are no updates, but I wasn't sure if that was really true. So I decided to use the terminal to run the command that checks for OS updates, and sure enough, there was a 1.6 gigabyte update that the store had just decided it didn't care about. So I sat through that update, rebooted, visited the store, and although the OS package updates were successful, that goddamn firmware update was still there. So then I decided a third time to install it through the command line. I rebooted, I saw that it was still there, and then I just decided to move on for now. So this was really not a good start, to be honest. Next, I wanted to install Firefox. So I found it on the App Store, installed it, and then clicked on Open to launch it. But for some reason the App Store seems incapable of doing even just that. Okay, whatever. I could just launch Firefox through the app drawer like usual, right? Nope. Firefox just kept on crashing. After some digging, I found out that the reason for this was because secureblue uses a hardened memory allocator, which is basically something that protects you from various memory-related security issues. And this is actually something that was written by the Graphene OS developers, so you know it's good. But it does break some apps, and so you need to turn it off for those apps. And there's no way to tell in advance whether a given app will work with it or not, so you just have to use trial and error to figure that out. The method you use to turn off the hardened memory allocator for an app depends on what kind of app it is. Everything from the App Store is packaged as a Flatpak, so you have to use flatseal to remove a specific environment variable for any Flatpak that breaks with the hardened memory allocator. Once I did that for Firefox, it did work fine. So already I think you can see that the secureblue user experience out of the box is really not good. It's not like the GNOME App Store has ever been any good, even on regular Fedora, but the number of weird errors and glitches that it seemed to have on secureblue was ridiculous. The good news is that the developers do plan on replacing the GNOME App Store with a new app store called Bazaar, which is apparently a lot more reliable. But that's still not going to be enough. I mean, a user who tries installing a popular browser from the official App Store on a fresh OS should not have to play around with flatseal and environment variables just to get that browser to run. Hopefully the secureblue developers can improve this experience in the future. Maybe they could have a database of apps that are known to break with the hardened memory allocator enabled, and then it could just be turned off for those apps automatically. I don't know. With that said, you probably don't want to use Firefox anyways, because secureblue comes with Trivalent, a browser that's based on Chromium but modified for better security. The downside to Trivalent is that browser extensions are disabled by default, because they can be terrible for security and even for privacy. I tried really hard to figure out an extension-free workflow, but I just need Bitwarden and Flocus and uBlock Origin, so it is what it is. And Trivalent does give you that choice. You can re-enable extensions if you want, and for some extensions you might have to also change some other settings as well, but all of this is covered in the FAQ. Next up, I tried installing LocalSend, an app that lets you send files between devices on your local network. It installed fine, but when I tried sending a file from my phone to the PC, it just wouldn't work. Now, because I had read the FAQ in advance, and I knew a bit about computer networking, I immediately knew what the problem was. secureblue blocks all network ports out of the box, so all I needed to do was just look up which ports LocalSend uses, and then open those ports up in the firewall app. Now again, this is not a big deal if you know what you're doing, but it is a terrible user experience for someone who either hasn't read the FAQ, or who doesn't know about ports and firewalls, or who just doesn't put two and two together and figure out the problem. It would have been really nice if the OS could have just detected that LocalSend was attempting to use a certain port, and then prompt me asking for permission to open that port automatically. Going back to the App Store again, the next thing I tried to do was install Android Studio. It took a really long time because this is a big app, and of course, the process crashed at the very last second. I tried again a bunch of times with no luck, and then I asked for help on the secureblue Discord server. It turns out that this was just another case of the GNOME App Store being totally worthless. When I tried installing Android Studio through the terminal, it went fine. Now, obviously, Android Studio specifically is not an app that most everyday users will install, but if this happened with one app, it could happen with any other. A separate problem was that when I tried launching Android Studio, nothing happened, and launching it through the terminal didn't help either. Turning off the hardened memory allocator and messing with a bunch of other settings was also a waste of time, but I'll move on for now and come back to that later. The next thing I tried was to enable fingerprint authentication so that I wouldn't have to type in my password all the time. Seems simple enough, right? I went into the settings, enrolled my fingerprint, and it seemed to work fine. But then when I logged out and tried to log back in, it just wouldn't ask me for my fingerprint. I would still have to type in my password. This problem was a lot tougher to figure out than any of the others so far. I tried looking stuff up on DuckDuckGo, I tried asking DeepSeek, I even got desperate enough to Google it. Eventually I went back to Discord and the developer was able to point me in the right direction. It turned out I just needed to run a single command in the terminal and my problem was solved. I think you're starting to see a recurring pattern here. secureblue just isn't ready for a novice user who just wants to install some apps and get to work, and who is not willing to spend time troubleshooting and running commands in the terminal, especially for basic tasks that you would expect to be able to do through the graphical UI alone. For now, this is not necessarily a deal breaker because secureblue's target demographic clearly isn't novice users right now, but hopefully someday they can improve the experience and polish it up enough for that to change. Also, I constantly found that when it comes to troubleshooting secureblue, search engines and LLMs are just a lot less useful than usual, even by 2025 standards. And that's just because of how relatively new and niche secureblue is, or even just atomic distros in general are. I also constantly found the Discord chat to be very helpful. The developers are really active on there, so that's definitely a good resource. On to the next thing. I did want to try some gaming, so I thought I could just install Steam from the App Store like you would expect, but it turns out that's not enough again. Just like Firefox, Steam also requires you to turn off the hardened memory allocator for it, but it needs more tweaks on top of that. It needs so many tweaks that the secureblue developers decided to just make a handy ujust command that will install Steam and make all of those changes automatically, so that's nice. But again, you would need to have read the FAQ in advance to know that that exists, otherwise you would just innocently install it from the store and then scratch your head when it failed to work. During installation, I was asked to re-enable X-Wayland, which is something that Steam needs, and which is turned off by default because apps that use X-Wayland can actually spy on each other, as in, they can visually see and record what's on screen in those apps. Now, for Steam alone by itself, this is probably fine, at least for me. I don't know what freaky games you're into. But once you've enabled X-Wayland, you really need to pay attention to which apps use it, because you wouldn't want something like a browser or a note-taking app, for example, to rely on X-Wayland. This is really disappointing because it's 2025. Apps really should all support Wayland by now instead of having to rely on X-Wayland. So I really don't know what the Valve developers are waiting for. Hey, look at that. Android Studio works now. I guess it also just needed X-Wayland. Of course, in the end I still failed to run the Android emulator from inside a container. It kept complaining about a GPU driver issue and crashing. It would only work when launched from secureblue directly, and even then I have to launch it with a ujust command that disables the hardened memory allocator. So again, you have to do a lot of trial and error to get some things to work. Now let's move on to some more advanced use cases. So far, everything that I've tried to install has been a Flatpak from the App Store. For most users that will be enough, but what if the app that you're trying to install doesn't come packaged as a Flatpak? In some cases, you'll be forced to install that package as a new layer on top of your read-only Atomic OS. In my case, I needed to install Mullvad VPN as a traditional package. So I downloaded the RPM file from the Mullvad website, opened up the terminal, and tried to install it. Of course, I couldn't just install it in the usual way using sudo dnf install, for a couple of reasons. First, the famous sudo command doesn't exist in secureblue. It's been replaced with something called run0, which is apparently way more secure under the hood, so you will have to retrain your muscle memory for this new command. Unlike sudo, run 0 doesn't have a timeout, so it will ask for your password every single time that you use it, whereas sudo usually doesn't ask you if you've already run it in the same terminal within the past few minutes. Also, instead of using DNF for package management, which is what Fedora uses, Fedora Atomic distros use a new command that you'll need to learn called rpm-ostree. So I needed to run rpm-ostree install, and I used the apply live parameter, which can save you from having to reboot. To be honest, I've had bad experiences with the rpm-ostree command, because when it fails, which happens more than it should, the error message is usually not helpful. In this example, error 203 just means that you don't have to use run 0 when running rpm-ostree. After I installed Mulvad, I still didn't see the app icon in the app drawer. Apparently, you need to reboot even just for that. So I rebooted, I tried launching Mulvad, and nothing happened. So then I went straight to the Discord this time, and I found somebody asking about the exact same thing. Turns out, Mulvad VPN uses the Electron UI framework, which is apparently really bad for security for various technical reasons that I'm not going to get into. You can pause the video or go to the link in the description if you want details. Anyways, in order to get Electron apps to work, you need to disable a specific SE Linux module, and secureblue does provide a one-line command to do this. After I did that, Mulvad did launch and it worked fine. So that was Mulvad. Next I decided to install Codium, which is an open source version of Microsoft's VS Code code editor. I decided not to use Flatpak this time, even though there is a Flatpak available, because that version would have been difficult to work with for a variety of reasons. I could have layered it onto the OS as a regular package like I did with Mulvad, but I decided not to do that either. There is a third option for installing software on secureblue, and it's called Toolbox. Toolbox gives you a way to run traditional, non-atomic distros inside of containers. It's really useful because inside the container, you don't have to deal with a read-only file system, and you have access to whatever packaging system you're probably a lot more familiar with already. So I ran a command to enable Toolbox, I created a new container, entered the container, and from there I could just follow the Codium installation instructions for Fedora, just like I would on a normal Fedora install. Once that was done, I ran Codium and it worked fine. So toolboxes are very useful, but they're not perfect, especially when it comes to their integration with the rest of the OS. As you can see, there's no desktop icon for Codium, and because it's in a container, you can't run it directly from the terminal either. You need to either enter the container first, or use the toolbox run command. Also note that toolboxes share your home directory, which is something you may or may not want depending on your use case. I like it because it means that I could have multiple toolboxes with multiple instances of Codium, and they would all share the same settings and extensions, because those are kept in the home directory. And yes, before anybody mentions the dev containers VS Code extension that I could have used for container-based development, just know that that extension is both proprietary and made by Microsoft. And that 1-2 punch makes it something that I will stay as far away from as I can. So, at this point, if somebody were to ask you about how to install software on secureblue, you could tell them that they could either install an app as a Flatpak, or as a traditional package inside a toolbox container, or just directly as a traditional package layered on top of the OS. Each method has its pros and cons, and it's up to you to figure out the best one to go with on a case-by-case basis. That person would then deeply reconsider their life choices and beg you to stop wasting your life on niche Linux distros and packaging formats. But what do they know, right? The crazy thing is, there's more. There is one more method you can use to install apps on secureblue, specifically command line apps this time, and it's called Homebrew. Homebrew is really nice because I was able to install a lot of command line apps that I would have otherwise been forced to layer in or put in a toolbox. But it's also frustrating, because now there are 4 different ways of putting software on your OS. At least there are auto updates for everything, except for what's inside your toolbox containers, so that's nice. One weird bug that I haven't been able to figure out is that secureblue's terminal startup has always been weirdly slow for me, and it got much worse after I installed Node.js, which is not something I've seen on any other system. And I've installed Node.js on a lot of computers. It can take 3 to 5 seconds for the terminal to become usable now, and it's really annoying. I haven't found a fix for this, and the people on Discord seem to have no idea either, so maybe it's just me. But this did happen on 2 separate systems, so it's definitely not just me. Okay, these next few issues are very niche and most people probably won't encounter them, so I'll go over them quickly. If you want more details about these, you can go to the secureblue Discord server, where you will be able to find my desperate pleas for help. First off, there is a strange bug that seems to be common to Fedora Atomic distros, where you can't just add a user to a group in the normal way that you would. Instead, you have to modify some file first. Another random bug I encountered was that when debugging an Android Flutter project in Codium, I couldn't set any breakpoints. This one really took a while to figure out, and to be honest, it almost made me give up on this whole project entirely, because I have to be able to work on Android Flutter apps on my PC. Basically, the issue boils down to VS Code just not expecting the home directory to be mounted in the way that Fedora Atomic-based operating systems do. The workaround was just to open the project using a slightly different path. Almost done. Next, if you need to modify the init RAM-fs for some reason, assuming you know what that is, just know that doing so is disabled by default and that you cannot use the dracut command to build the init RAM-fs like you could on regular Fedora. Instead, you have to use rpm-ostree to enable that, and then builds will happen automatically. Doing this will significantly increase the amount of time that rpm-ostree commands take to run. This is not an issue or a problem per se, it's just a different way of doing things, and one that is very hard to figure out because of the lack of documentation. The last problem I'll talk about, also not something that most people are likely to run into, is when you need to make custom changes to the contents of the read-only core OS file system. Obviously you can't do that directly, since the OS is read-only. The only way to make changes is by layering in RPM packages, which means if you need to make some custom change, you'll need to learn how to build your own RPM package. This is deceptively difficult. It looks simple enough on the surface, but I kept running into problems. The main one being the inability to easily update from one version of a locally built RPM to the next. This is currently an open issue on the rpm-ostree GitHub issue tracker. Okay, things got pretty deep at the end there. This list of issues and complaints is basically the summary of my practical experience with secureblue. At least the interesting parts that were worth talking about. Once I worked out all of these issues and got used to a new way of doing things, secureblue does work really well. I can game, I can browse the web, I can develop software, and do everything else that I need to do. My overall impression of secureblue is that while it does have real bugs and real issues with user-friendliness, usability, and user experience, it also has a lot of potential. It has some really good defaults out of the box that you are free to change if you want to, and I just really like the attitude of the developers who go out of their way to explain their decisions and tell you exactly why things are set up the way they are. Most of the problems I had with secureblue were not because of the OS itself, but because of the fact that the rest of the Linux ecosystem around secureblue just isn't ready for it, in my opinion. A lot of the apps that people will want to use on their PCs, like some of the ones I mentioned, just require you to either turn off some security feature, or they need to write to some read-only part of the OS, or they have some other obscure bug that only shows up on secureblue, or they're trying to use memory in a way that they really shouldn't, which is what makes them crash when the hardened memory allocator is in use. Or they rely on some bloated and insecure dependency like Electron, and so on. Secureblue does give you the choice to compromise on security and make those apps work, but it sucks that we have to make those choices at all. And then there are things like the integration between Toolbox and the rest of the desktop not being great, or the fact that you have to mentally juggle 4 different ways of installing software, which each having its unique quirks. There's the fact that people are used to a certain mental model of how Linux works, and the idea of an atomic OS where most apps run in a Flatpak or other container will take time to get used to. And because the community around these OSs is so small, there isn't nearly as much documentation or help out there for troubleshooting as there is with other distros. With all that said, give it time. For those of you who are familiar with Graphene OS, I remember using it on a Pixel 3 XL years ago, back when you would have to kill the Play Store after every time you used it to install or update something. And there were a ton of other similar user friendliness issues. These days it's the exact opposite. It's very polished and I would have no problem recommending it to anyone. So if secureblue continues to get enough attention from its developers and enough support from everyone else, I think it will be really interesting to see where it goes in the future and what it looks like years from now. Personally, I will be keeping secureblue on my main laptop for now, and I might even switch my home server over to it at some point as well. So hopefully you found this interesting, and if you want to see more random Linux and software crap from me in the future, you know what to do.